Yeah, welcome. So, in today's lecture, we'll be studying about this numerical problem. This is very important numerical with respect to the examination point of view. So, the question states like this: for a first order system, find the output, find out the output of the system, find out the output of the system. Okay, here also it is writing a bit, so I'll drag it down. Yeah, find out the output of the system when the input when the input applied applied to the system is a unit ramp function. And what else it's asking also to sketch the response, sketch RT and CT, and show the steady state and show the steady state error, show the steady state error. So how do we go about the system? See, in the first order system, your CS, this is your output by input, which is the transfer function, is equal to first order means you will have only one term of S. So it would be 1 by S plus T. This is the first order system. So what it is telling, what is R of S? R of S is the input. What is it telling? Input is a ramp function. So we know inside ramp function, the input would be equal to 1 by S square. So we have to substitute in this CS RS value 1 by S square. So we can substitute here. We can write RS divided by after cross multiply S plus T. So this RS value over here can be written as 1 by S square S plus T. Now we have to do a partial fraction expansion. So this is a cubic term. So the partial fraction expansion would be A by S square plus B by S plus C by S plus T, right? This is the partial fraction expansion. So in order to get this S, now if I take this expression common on this side, so I have with respect to A, I have a one common term with respect to A, that is S square is there. So I need only the function of S plus T. But with respect to B, okay, you can see the one S term is there, but one S term is missing. So it would be S into S plus T. And here with respect to C, what is the term in the partial fraction expansion you have to take? You have to take simply S square term and equate it to 1. Because in the denominator part now it is same for that. The denominator part would be S square S plus T. Here also the denominator part is S square S plus T. So here we can just cancel out these denominators. We are not interested. We are only interested now. Just simplify this equation A of S plus AT. Then you have B into S square. Then you have plus B S of T. Then you are left with plus CS square. Now combine those equations which have the S term and the S square terms and the term. See, A of T is not having any term, so let it be in the side A of T. Let me write the higher power S square terms. Which are the S square terms? S square terms are these are the S square terms. Black ones, B S square and C S square. So I'll write B plus C. And which are the S terms? AS and BST. So S terms I can write AS and BST. So here it could be A plus BT. And rest will follow AT is equal to 1. So this is a constant value. So I can say that my AT value is equal to 1. So my T value or A value, in fact, AT value is equal to AT value is equal to 1. So my A value would be equal to 1 by T. Okay. On a similar grounds, if I check this equation, the equation number A plus BT equation. So there is no S term on that side. So I can write A plus BT value to be equal to 0. So that would mean my BT value is equal to minus A and my T value would be equal to my B value would be equal to minus A by B. So definitely I know my A value is equal to sorry, b value would be equal to a by t. So I know that my a value is equal to 1 by t. So here I can write this expression as minus 1 by t square, right? So it will come minus 1 by t square. Similarly, I can go for this term b plus c term, s square wala term. I can write b plus c also equal to 0. Directly, I can write the value c is equal to minus b. Already I have got the value for b. So the c value would be equal to 1 by plus 1 by t square, because it's minus of minus 1 by t square, which is nothing but plus 1 by t square. So I got these terms over here. Now what I have to do is that I have to substitute these terms. So you have got this term. So let me take it to the next page. So I got these values. What I'm going to do is that I got the value of, let me see. Yeah, I got the value of A as 1 by T, and I got the value of B as minus 1 by T square, and I got the value of C as 1 by T square. So what I'm going to do is I'm going to substitute this value in the original equation, which was 1 by S square S plus T, which I had divided as A S square plus B S plus C S plus T. So in these terms, I'll be putting the value. First value is 1 by T, 1 by S square into 1 by T. Second value is, it's plus, so it is minus 1 by T square for the B value, minus 1 by T square into 1 by S. And for the third value, C value, you see that my C value is equal to 1 by T square. It's in plus only 1 by T square into 1 by S plus T. Now, if I have to take the if I have to go for the Laplace inverse of this, so Laplace inverse of 1 by S square, I already know what is the Laplace inverse for the 1 by S square term. So the term, it would be equal to t, small t, Laplace inverse, because t ramp function will give Laplace inverse of 1 by S square. And what would be the Laplace inverse of 1 by S? Laplace inverse of 1 by S is 1. So this is the Laplace inverse terms. This is the Laplace inverse term. Similarly, if you have the Laplace inverse of 1 plus 1 S plus t, so it is nothing but as e minus t into t. So this is the Laplace inverse that I'm going to get. I will substitute these Laplace inverses, and I'll get this value over here as 1 by t into t. From here, 1 by t into t. Then this is minus 1 by t square. So the value would be minus 1 by t square will remain as it is. Okay. And this Laplace inverse of 1 by S is 1. Okay. Then I have the term 1 by t square. It will remain as it is. And here I get this value e minus t. Now what it is asking, it's asking to sketch. Now in order to sketch CT and RT, what I have to do is that I need to take some value. Okay, so let me take the value of t equal to 1 in this equation. And how I will plot this, I'll show you. Normal ramp function, this is the curve. Okay, here. Okay, yeah, from here to here, let me draw it. Okay, so for the normal ramp function, curve would be equal to, yeah, from here to here, but this is the normal ramp function that I've drawn. Okay, okay, normal ramp function r of t. And what I need is, I need the value r of t is equal to t, but I need this value. So what I do is I draw another function. I'll take a different color. Sorry, I'll take a different color. What has happened here? Yeah, I'll take a different color. So I draw a different function over here. Okay. So this value over here, let this be 2, and this is the 2 value here. Okay, at this point, this value would be 4. This is the 4 value. Let this value be equal to 6, and this value would be equal. This is 2, this is 4, this value is equal to 6. So what happens is this here, this I have drawn for, put the value of c of t for t is equal to 1, and this value r of t when I put for. So this is the function r of t. So here you can see that this part here between this portion represents the steady state error. Hope you have enjoyed the session and liked it. And we'll be bringing more videos. If you are new to this channel, please subscribe it. Thanks a lot. I'll end this video. Bye bye. Take care. Again, bye.